Okay, so here's section H, a little about factorising. I did this in class, but my microphone wasn't on for the remote learners, so I'll just go through some of the main points. So the key thing for factorising is to actually just change the style of it. Okay, this is not solving an equation. This here is actually an expression, and all we're trying to do is just write it in a different format. Okay, one of the big mistakes people make is just misreading the question. They see factorising and they end up writing, some kind of solution. Well, there is no equation here, it's just an expression. So the first thing is try and take out a single factor. So always search for single factors. Once you've got a single factor, you've kind of rewritten the expression in a slightly different form. And now look at the remaining part in brackets and see if you can factorise further. And this is one of those cheeky ones where x times x, 2 times 2, 1 positive, 1 negative. This is the difference of two squares, so it's x squared and 2 squared, the difference of two squares. Okay, so that's something that could be quite familiar to you, and that indeed is the final answer. Remember, one of the common mistakes is people go on and do this, x equals 2 or x equals negative 2. This is definitely incorrect. This is an expression, okay, and it's not an equation. An equation demands some kind of solution, x equals. This is an expression. Okay. If we go down to part C now, this will look quite familiar to you as well. This is a quadratic expression, and straight away you think about a single factor. There is no common single factor, so I think we're straight away to 2 brackets. And again, you may have been taught something about splitting the middle term, maybe changing the 8x into maybe 4x plus 4x possibly, or you may have some kind of scissor method. Whatever method you've got for factorising quadratics, just use it, and I'll have a look over the next few weeks at your techniques. But this is definitely x and x. This is plus 4 and plus 4, and therefore we can write that in a tidier fashion. It's x plus 4 multiplied by itself, so that means it's all squared. Okay. Up here now, this is quite an interesting one. Again, we're going to take out that single factor first. 2 comes out first, a squared minus 2ab plus b squared. And it doesn't look like anything else will happen because it doesn't quite look like this one where it was all in a single variable with x's. It seems to have 2 variables, a's and b's. But this is actually just in a sense a disguised quadratic, because we can do it in two brackets, a times a here, b times b here. If we put a negative here and a negative here, then we can rewrite it as 2a minus b all squared. Now you can convince yourself with the expansion, because if you actually expand this, a squared, a times b times a, which is the same as a times b, they're both negative, so that would give negative 2ab, and then negative times negative is positive b squared. Okay. So something that you should have commit to your memory is a minus b all squared and a plus b all squared. Now in class I did this beautiful mistake that students like to make. Just square both the terms and subtract them. Square both terms and add them. Clearly this is completely and utterly wrong because we have middle terms. Okay, so commit to memory. A minus b squared equals a squared minus 2ab plus b squared, and a plus b all squared equals a squared plus 2ab plus b squared. Okay. Now the final one down here, we discussed this in class and we said, well, one valid way would be to expand first. Okay, so when we expand, that would be x squared minus 3x is minus 6x plus 9 minus 3x plus 9. Collect like terms. And now we're kind of back to factorising a quadratic, similar to this one. And so you're just going to choose, your method for factorising a quadratic. Okay, I'll just go straight to the solution because I think I can see what it'll be. I need x times x. I need to make 18. That'll be 6 times 3, and a negative will sort me out. Okay, so that looks fine, doesn't it? But you've actually got a quick way of doing it. So if I just choose a different colour, do this in blue, if I actually rewrite the first line as x minus 3 squared and then take out a negative 3 as a factor for the next two terms, this will be actually x minus 3. And can you see now that in this first term x minus 3 is a factor, and in the second term x minus 3 is also a factor. So we can actually take out x minus 3. I tend to put a large parentheses just to see what might happen in here. And so x minus 3 times by something has to give us x minus 3 squared. Okay, so clearly in here we've got an x minus 3, and now x minus 3 times something has to give us negative 3 times x minus 3, and that should be simply negative 3. And when you finish that off, that's x minus 3 into x minus 6, which is exactly the same answer as before. So just have both of those techniques at your fingertips. We'll scan back through. Make sure you've got an understanding that, you know, when you square an expression, you expand and there's some middle terms. Don't commit the beautiful mistake there. Factorizing quadratics, quite straightforward, but we actually teach that, you know, as part of the course. We don't assume that you can do all types of quadratic factorizations. It's part of the course, and of course that first little step of factorization, taking out a single factor first and then looking at the remainder to see if it's easier to factorize. Okay.